Hello everyone, welcome back again to the YouTube channel Devotion of Knowledge. As we are on the way to our C++ STL playlist, we have discussed up to unordered set, but in this video we are going to discuss about the problem on unordered set. But before that, I forgot in the last video that why unordered set takes O of one time complexity for fetching the data. So here let us understand why of one time complexity. It's what is that particular technology or specific technology that unordered set is using, due to which it is resulting into so much faster of data accessing, inserting the data, as well as deleting the data so fast. So reason is that it uses hash table. It uses hash table. Now, as I told you, set uses red black tree data structure for implementing in the backend, while unordered set uses hash table. Means it stores values in terms of, means for example, the one is stored corresponding to some hash value, two is stored corresponding to some hash value. So it is storing the data in sorted form, as well as not unique element. So not sorted form, but it stores unique data, so it follows hash table instead of red black tree. This is the main logic. And let me tell you one thing, as we saw, or you can insert, or we can do any kind of nesting in case of set data structure, but in case of unordered set, or in case of unordered map as well, that we will be studying in near future, we can't do any kind of nesting. We can only insert standard data structures such as integer, float, character, and double, and all that. We can't use unordered set of vector and all that. It is not supported because the hash values are not there. Hash values are not there for such nesting of data structures, such as we can say vector, string, etc. But hash values are there only for elementary data structures, such as I told, integer, float, and all that. So please keep this thing in mind. To access or to have nesting, to achieve nesting, you guys can check out, there is a boost library of C++, which has already implemented or inbuilt such kind of hash values, which supports nesting in unordered set as well. But in case of bits slash stdc++.h, it's not there. No worries. Let us immediately switch our conversation to the problem that we were going to that we are going to understand. Let me remove solution from this side. Okay, no worries. Otherwise, you guys will be directly switching to the solution. No one will be interested in understanding the question. Okay. The question is like that. We are given an unsorted array. Please remember this thing. Unsorted array integers of nums. And we are supposed to return the length of the longest consecutive elements sequence. Now, longest consecutive elements. For example, here in this case, 100, 4, 200, 132. Longest consecutive sequence of the numbers is 1, 2, 3, and 4. While in this case, it is 0, 1, 2, 3, 4, 5, 6, 7 up to 8. And also, if 0 is 2 times present into the array, but we are going to consider it only once. So, we are returning 9 in this case. But there is a catch up in this problem. You must write an algorithm that runs in of n time. Okay, no worries. We are not knowing anything like unordered set right now. Then how we will be approaching the question? Means as one array is given of some random numbers, and let us say it as nums. Here we will take some set data structure, and we will be inserting each and every value into the set. And for example, if 2 is present, we'll be checking for 3, 4, dot dot dot, and for backward as well. 1. But will it be running in O of n time complexity? It will be taking log n. And if we try to optimize it maximally, it will be always coming to O of n, because once we have to iterate through the array, it is compulsory or mandatory. So it will result, or means it will be finally optimized to O of n log n. But we are supposed to do it in O of n. How to do it? Okay, we will do it because we know there is something like unordered set. We know it. But let us first try to optimize this, that how we will be doing in this O of n logic. First of all, we will be inserting all the elements into the unordered set. Unordered set, it is unordered set, for example, and we are inserting all the elements of nums into this. Okay, now what's the array given? 100. Okay, 100, 4, 200, 1, 2, 3. Okay. This is the array given to us. Now we are trying to optimize it to by means into O of n. How? First of all, we have to make a limit that I will be only considering, for example, if I encounter 2 here, then I am supposed to check in backward direction 1 as well. Also in forward, means 3 and 4 are also present. So can I make some logic, or can I make some condition which makes only this checking fashion, means this checking in only one direction? Yes or no? Yes. How? We can make this by restricting, or by considering the least or the maximum element possible. For example, here I am coming 4. So is there any element uh, greater than 4 present into the array? Yes, they are 100 and 200. So if a subsequence is present, we won't be starting from 4 because there are some greater elements present from 4. So we won't be trying 200. Is there any greater element present than 200? No. So we will be trying from 200. That I will be starting 200. So I will be checking for 100. I will be checking for 90 and all that. But it is not feasible. Instead, why not to check from the lowest element possible? Okay. Here we come. Uh, okay. Is the 100 least element into the array? No. Is 4 means, is there any smaller element present than 4 into the array? Yes, there are 3, 2, 1. There are many elements present less than 4. Okay, so we won't be iterating from 4. Is there any smaller element present than 200? Yes, it is present. So we won't be considering it. Is there any element present than less than 1 present into the array? No. So if my sequence is present, if I am not telling that it is present, but if my sequence is present, then 1 will be the starting element of that sequence. Are you guys getting what I am trying to say? Let me repeat. If the sequence is present, if it is not mandatory that every time the sequence will be present, but if the sequence is present, then 1 will be the smallest element possible into the sequence. Okay. Then now we'll be, yeah, 1 is the smallest element. Okay. Now I will be checking for the next consecutive element. It is 2. Is 2 present? Yes. Now I will be checking for the next. Is 3 present? Yes. Now next one. Is 4 present? Yes, it is present. So now my length is maximum 4. Now I will check for 4. That is 5 present? No. So you might think that it may go up to of n square in some case, but no. For example, my complete array, example, my complete array is like this: 5, 4, 3, 2, 1. Also 6 and 6, 7, like that. 6, 7. So as per our logic, we'll be checking for the least element present into the array. So least element present in the array is 1. So this loop ran for O of n. Now for this one, we'll be checking for the consecutive elements. For this one, we'll be checking for 2, 3, 4, 5, dot dot dot. But this is not happening every time. This is happening only for the one time. So it will be O of n plus O of n, which is O of 2n, but it is resulting into just O of n because we neglect all the constant present into time complexity. And for checking that whether the element or the least element or not, whether it is least element or present or not, we will be checking element less than 1, means is there any element present less than 1, which is 0, -1 and all that. So no. So for checking the further elements present or not, we will be using unordered set, because if 1 is present, we will be checking for 2 in a dot set. Is 2 present, is 3 present, is 4 present, and it will be done in O of, I'm sorry, it will be done in O of one time complexity, which is constant time complexity, because it's the USP of unordered set. It performs fetch, insertion and deletion operations in O of 1. This problem can also be done using normal set, but it will be taking log n time complexity for searching. So it will be resulting into O of n log n. I hope this logic is clear to you. It's a standard problem of data structure and algorithm, which we have understood the logic. So now it's time for us to understand the code. Okay. Here I have just written some base cases. If the nums dot size is already 0, just return 0. Now we are taking, as you can see, on dot set. Let me zoom it. Otherwise, if we zoom it, it won't be able to cover the whole page. No worries. Okay. Now we are inserting each and every element into the set data structure that we have taken. Now we are iterating through each and every element present into the set data structure. Now we are checking that if is there any element lesser than, means lesser element present. If it is s dot end, means if there is no element present which is less than the current element, it means it can be, I'm not saying it is, it can be starting over that longest sequence present. So we will be checking up to while that next elements are getting present. So find num plus 1 is not equal to s dot end. It means it is present into the set data structure. And remember O of one time complexity. And if the next element is not present, it will be coming out from the loop and we will be just taking maximum of answer every time. Otherwise, if it is not present, means it is not least element, and we are just continuing. And finally, returning the answer. And as per the catch given into the question, we have done it in O of n time complexity using our signature data structure unordered set. So I hope guys this video is clear to you as well as the approach to the problem. As you can see, without unordered set, it was not possible for us to do the problem in O of n. And yes, also using unordered map, we can also solve this question in a similar manner. But you guys are not much or still aware about unordered map right now. We will be studying into the further videos. But right now, I think this much is sufficient for unordered set. And that's it for the unordered set, because it is not that much of deep topic, but it has a wide application into the problem solving. While fetching is to be done in constant time complexity. So whenever you are supposed to do any kind of fetching or accessing the data, or doing, or there is a need to do fetching and all that in constant time complexity, please use unordered set in such cases. So I think guys, it's enough for this video and we should conclude. Till then, we will meet in the next video. In the next video, we are going to understand the most interesting type of set container, which is ordered set, which is also can be classified as policy based data structure, PBDS. So in the next video, we will be understanding ordered set. Till then, keep learning, keep hardworking. Thank you.